Computer-generated images and visual environments have improved dramatically over the past couple of decades, thanks to the modern technologies being developed both as software that translate parameter-based computations into visual outcome and hardware as the backbone of the process. And with the rapid advancement in the field of computer simulations and visual creations, the term visual fidelity within the context of this project describes the quality of the reconstruction of real-life original subjects on the screen. The broad term includes many aspects to be considered. However, the focus of this project will be the parameters the designers use to produce virtual environments. The ultimate aim is to achieve the highest level of realism and visual fidelity whilst running the simulation with minimum performance requirements and workload on the machine. Visual fidelity as visual stimuli is discussed through understanding the interrelated concept of the willing suspension of disbelief, which describes the willingness of users to react to fictional events or unreal visual elements as if they were real, to sacrifice logic and realism in order to become emotionally involved in the experience. From here, the connection between visual fidelity and the willing suspension of disbelief was approached. To better understand the influence of visual environment fidelity on the user's suspension of disbelief, the project raised the question: to what extent do visual fidelity stimuli influence the willing suspension of disbelief? In other words, can a high level of visual fidelity trick the mind into thinking what being witnessed is a form of reality? To answer the question and to go deeper in analyzing visual fidelity role in realism and immersion, the project creative work will be examined through the design of a virtual environment, as well as by reflecting on users' feedback that helped develop the project at its various stages. The project aim was to design a realistic virtual environment as a digital reconstruction of a real-life building. Several options were considered. However, Soraya Opera House in Istanbul City was selected, considering the reasonable scale of the building with the limited time frame of the project. Choosing a real-life building also proved helpful in a project that aimed at finding a connection between the physical and the virtual environment. The attempted realistic recreation of the building involved working on the structure of the building itself, as well as all the elements it contains: furniture pieces, decorations, materials, and textures. Copying the exact look of the building exterior and interior space is an important consideration for the original concept. This was also considered during the user participation experiment. It was found that the familiarity with the original is more stimulating of the user's suspension of disbelief when navigating through the virtual space. This leads us to believe that suspension of disbelief is a relative measure, the level of which is influenced by users' knowledge of the subject and the technical aspects of the work, which was a result of the feedback and survey answers. Working on the virtual 3D environment started with a simple 2D drafting for the building floor plans and cross-sections. This was based on images provided by the firm that did the latest renovation of the building in 2006. The outcome of this stage was computer-aided design drawings with high accuracy of measurements. Later, the 2D drawings were used to model the basic shape and structure of the building. This focused mainly on publicly accessible areas and spaces that will be part of the final production. The rest of the 3D models were then created progressively as the project developed. With very high accuracy and resemblance to real building objects, furniture pieces were modeled, decorations were copied, and the overall image of the building progressively improved throughout the project duration. Taking into account the realistic state of surface appearances, materials and textures were designed as well. Customized maps were created to give each object its distinct features and appearance. A good example of this process is the illustration of the building logo, which was later used in modeling auditorium door plaques, light fixtures, keys, as well as designing customized materials for auditorium seats, chairs, and performance piano. 3D objects and scene elements were then compiled into one build. The initial construction of the virtual environment is now complete. Further work included experimenting with lighting, shading, visual effects, and various other parameters that generate and control the visual outcome. Parameters were adjusted and experimented with, balancing two critical factors: visual quality of the space and performance requirements needed to navigate through the virtual space in real time. The project tried to reach an optimal balance between highest quality of production and lowest performance requirements. This step employed several techniques of optimizing the scene for better results, as indicated by project documentations. Spread throughout the whole project development, 8 variations of the scene were established, each with its unique visual features and level of visual fidelity. Those were tested by the small group of participating users, provided feedback, helped reaching the final project outcome as a realistic virtual environment with relatively high level of visual fidelity. The next step involved designing the visual narrative and the environmental storytelling to enhance the experience within the virtual place. The project argues that thematically accurate visual clues and interactive narratives will enhance the visual experience fidelity and will bring realism to a higher level. This was later confirmed by survey questions answered by the experiment participants. With that in mind, constructing the narrative was an important part of the project to consider. To explore the various models of linear and non-linear interactive narratives, 2 parallel yet separate chains of events were designed to simultaneously occur in the scene. The 2 separate narrative parts meet at certain points. The decisions made by the user in one path will influence the outcome in the other. This is a demonstration of the parallel model of non-linear narratives. The first path is presented in the form of scheduled tasks to be completed in order for the performance to start, with 2 major events that will happen at specific times indicated by the opera clock. The linear path must finish one set of tasks before moving on to the next. However, each set of tasks is a demonstration of the non-linear model, where the user can rearrange the narrative segments. As long as all tasks are finished on time, the order of completion makes the experience non-linear. The second path of the narrative is based on the fan fiction plot of La Traviata opera. This path of interactive narrative starts with visual clues in the foyer of the building. This leads to location of keys, locked doors, and further hidden clues. The user will have the option to make a choice and influence the storytelling in a predetermined set of paths, which is an illustration of the branching model of interactive narratives. At this point, scripting will interfere with the plot. The script will randomize the outcome, leading to a probably different path even when the user makes the same choices each time the narrative is repeated. This is a good illustration of the dynamic model of non-linearity. The user will be asked to choose and send an encrypted message through the piano using computer keyboard keys. Eventually, 2 distinct conclusions will be reached from multiple directions. If the tasks from the first paths were successfully completed, the performance will be announced to start on time, leading to the final clue that asks the user to play a piece of the opera on the piano. Failure to complete the tasks will lead to different conclusion within the second path of La Traviata plot. Upon the completion of project development and experimentations, the project came to a final conclusion. Visual fidelity in a virtual environment is key in the willing suspension of disbelief. And despite the rapid advancement of technologies that produce virtual realities and interactive experiences, suspension of disbelief remains a voluntary willingness within current limitations discussed in the report. The report starts by exploring the first theme of visual fidelity aspects, before moving on to argue that visual narratives and interactive functions play a major role in the fidelity of virtual experiences. After examining the willing suspension of disbelief, which is the second theme of discussion, the final chapter highlights the influence of visual fidelity stimuli on the willing suspension of users' disbelief. Future project development potentials conclude the report and mark the beginning of a new journey of design and creation.